Well, let's take a look at our first review chapter, and I'll skip around. I won't cover all these topics. We just don't have time to do everything, and I'll go for approximately an hour, hour and a half, and then I'll answer any questions you have. Okay, identify subsets as inequality symbols, interval notation. Evaluate absolute value. First one thing I want to talk about is exponential expressions and square roots and cube roots. Now let's take a look at 2 to the 4th power. First off, here we got 2 to the 1st. Now when you get the 2nd power, that's referred to as 2 squared. Although you could say, no, I didn't put a power on that. Okay, 2 to the 1st power. Although you could say 2 to the 2nd power. Now if you get 3rd power, that means 2 cubed, or 2 to the 3rd power. And then after that, it really goes back to 2 to the 4th power. Now if you got 2 to the 4th, what that 4 means, that's an exponent. It means that we're going to multiply 2 times itself 4 times. So again, the number of 2's matches your exponent. Well, 2 to the 4th gives us 16. And that'd be your answer. Now if I had this problem, negative 2 to the 4th. Got a note that goes along with this. The note says, the exponent only affects what is to its immediate left. Unless there's parentheses, then it affects everything inside the parentheses. So for this problem here, the exponent only affects what's to its immediate left. So it does not affect the negative. That just carries down. So 2 to the 4th, that means we got 4 2's, which gives us negative 16. Now on the other hand, if they wanted it to be affected, they would put parentheses around negative 2, so it would affect the negative also. Because what's to its immediate left here is parentheses, and then that 4, that exponent applies to everything, which means we're going to have negative 2 times itself 4 times. Negative 2 times negative 2 is 4, times another negative 2 is negative 8, times another negative 2 is 16. So 16 would be your answer. Now square roots. This is what a square root looks like with this symbol here. And what we do is we write the prime factorization of whatever number's inside. So 4 we rewrite as 2 times 2. Now with square roots, we're looking for pairs of something. Here's a pair of 2's, so a pair of 2's is going to come out in front as a single 2. And that's our answer. Now if I have something that looks like this, square root of 12. Well, 12 is 2 times 2 times 3. And again, we're looking for a pair of somethings. Here's a pair of 2's. So a pair of 2's is going to come out in front as a single 2. And we're left the 3 inside. You can't bring it out because you need a pair of somethings. And that's just a 1, 3. Now if we have a 3 in this slot right here, if you don't have a number in there, it's by default 2, it's a square root. And you're looking for pairs of something. If you have a 3 there, we're looking for a set of 3 of something. If I do the prime factorization of 8, that's 2 times 2 times 2. And you notice we have 3 2's. So 3 2's is going to come out in front as a single 2. And that would be our answer. And it works along a similar idea if you have the fourth root, fifth root, so forth. Now that's our evaluating exponential expressions, square roots, and cube roots. Let's take a look at the order of operations. We have a way to remember what to do. Please excuse my dear Aunt Sally. Now the first letter of each word tells us what to do. Now the P, that is for parentheses. And we do whatever is inside the parentheses. Now that doesn't necessarily mean get rid of parentheses. It may, but that's not necessarily what it's saying. It's saying you do whatever's inside the parentheses first. The E, that's for exponents. The M is multiply or divide. That's what the MD stands for. As you encounter either one from left to right. And Aunt Sally, the A and S, add or subtract as you encounter either one from left to right. Now this tells us how we work a math problem. You're trying to simplify it, and this tells you what to do in what order. Let me erase this. For example, if I had 3 minus 2 squared to the third power minus negative 4 squared. Please do what's inside parentheses. Well, we got parentheses over here, nothing to do inside of it, but here's parentheses, and within this parentheses you still have to follow your order operations. Please excuse, so I do the exponents first. So we're going to have 3 minus 2 squared is 2 times 2, which is 4, and everything else carries down. Still doing what's inside the parentheses. Here I got 3 minus 4. That gives us negative 1 to the third power minus negative 4 squared. Please, nothing left to do inside the parentheses. Excuse, exponents. We do have exponents. Remember, your exponent only affects what's to its immediate left unless there's parentheses. So this one has parentheses. So negative 1 to the third power. And if you need to do this over on the side, you do. Negative 1 to the third is negative 1 times negative 1 times negative 1. Negative 1 times negative 1 is positive 1 times another negative 1 is negative 1. Minus negative 4 squared. Well, negative 4 times negative 4 gives us positive 16. And then last thing, add or subtract. Negative 1 minus 16 gives us negative 17. And that'd be our answer. Whenever you're working with numbers and you're trying to simplify them, follow your order of operations. Let me erase that. Now we get down to section R.2, models, algebraic expressions, properties, real numbers. And we got our use algebraic models, identify terms and coefficients, Apply properties, simplify algebraic expressions. Well, we're going to focus on this last one, simplifying algebraic expressions. Let's say we got 3x plus 4x. These are terms. So let's talk a little bit about a term. Variable, of course, is a single letter. A term is a number times a variable. And I put an S on there because you can have more than one. Or a variable times a variable. And again, I put an S on there to indicate you can have more than one. Examples: 5 is a term, it's a number. 7x is a term, it's a number times a variable. X squared is a term. Now you might look at that and say, well, you didn't say anything about exponents. How's that a term? Well, I said a variable times a variable. Well, x squared means x times x. That's a variable times a variable. We didn't say they couldn't be the same. And you could have like 7x to the third. That would be a term, because you got a number times a variable, and I got an s on that variables. X to the third means x times x times x, so we got 3 of them. When we say variables, we're talking about with multiplication in between them. Now we have something called a coefficient. This is the number in front of the term. We have our degree, which is the largest power of x. And then we got something called like terms. This is where they have the same variable. Now put an s on there because you can have more than one, to the same power. So this one would be considered a like term. They both have x to the first power. Now to combine like terms, you add or subtract the numbers in front of them. 3 plus 4 gives us 7, and then we just have a single x. So our answer is 7x. Now you could have, like for example, 3x squared minus x plus 2 minus 2x squared plus 7x minus 1. Now in this case, that first set of parentheses isn't doing anything, so I can drop it. And whenever you have a minus, a negative out in front of your parentheses, just flip the sign of everything inside. So that's going to flip the sign of the 2x squared, the 7x, and negative 1. The positive 2x squared becomes a negative 2x squared. The positive 7x becomes a negative 7x. And the negative 1 becomes a positive 1. Now like term, same variable to the same power. Here we have an x squared, and here we have an x squared. 3 minus 2 is 1, so we're going to have 1x squared or x squared. Here we got negative x and negative 7x. Well, that's negative 8x. And then 2 plus 1 gives us 3. That's our numbers we're combining together. And that would be our answer. Now, integer exponents in scientific notation. So let's take a look at this. If we have x to a power times x to a power, then what you do is you add the exponents. So this would be x to the 5 plus 2, which is x to the 7th. Now they don't have to be numbers like this. You could have x to the 1/2 times x to the 5 halves. It's same principle. You got x to a power times x to a power. The x's are the same. Now they might be variables, might be numbers. You could have 3 to the 1/2 times 3 to the 5 halves. Same principle holds true. We add the exponents. So we got 1/2 plus 5 halves which gives us 6 halves, which gives us 3. So that gives us x to the third. Now the property for that is, you got x to a power times x to a power. You're going to add the exponents. On the other hand, if you got one exponent you're raising to another exponent, you multiply them together. So this would be x to the power of 7 times 2, which is x to the 14th. And a property on that says we got x to the m power raised to the n power. That's going to equal to x to the m times n. Now if you have something to the 0 power, anything to the 0 power is always equal to 1. And I'm going to put that up here as actual property. So that's equal to 1. Now let me erase this, then we'll look at some more. Say we got x to the 8th over x squared. So you got x to a power over x to a power. Or you could have any variable. Note, if you have x to a power over x to a power, then subtract the smaller exponent from the larger exponent, and you have x to that power where the larger exponent was. Let's say it was located, and 1 in the other location. Okay, so this we got x to a power of x to a power. So we're going to subtract the smaller exponent from the larger one. 8 minus 2 is 6. So we're going to have x to the 6 where the larger exponent was, which was up on top. And then I'll put a placeholder of 1 down below, because you can never have a fraction with a blank on top or bottom. And x to the 6 over 1 is x to the 6. Now if I had x to the 4th over x to the 11th, again you got x to a power over x to a power. So you can subtract the smaller exponent from the larger one. 11 minus 4 is 7. So we're going to have x to the 7th where our larger exponent was, which is on the bottom. And then we'll put a placeholder of 1 in the other location. Now there's actually a property for that. I don't really like the property. It says if you got x to a power over x to a power, you rewrite that as x to the m minus n. It's not a bad property, but the method I just taught you for handling this is much easier, because you avoid negative exponents. Now let's take a look at negative exponents. Let's say I have 1 over x to the negative 5. Well, we never want negative exponents. So I'm going to take this x to the negative 5 and move it up on top. Now when you move x to a power opposite of where it's at in a fraction, so if you have it in the denominator, you move it up to the top, the numerator, or you move it down, the sign of the exponent changes. So this x to the negative 5 becomes x to the positive 5. And since there's nothing left down here, we'll put a placeholder of 1. And x to the 5th over 1 is x to the 5th. On the other hand, if I got a negative exponent to begin with, I got x to the negative 7. Well, I said we're going to move it opposite where it's at in a fraction, but it's got to be in a fraction first. So we'll put the x to the negative 7 over 1. And then you're going to take the part with the negative exponent opposite where it's at in a fraction. So I take the x to the negative 7 down below, and it becomes x to the positive 7. Now since there's nothing left up here, we put a 1, and that's actually our answer. Now you may have problems that use combinations of these types. For example, if I have x to the negative 2, y to the 3rd, over y to the negative 5, x to the 7th. our order of operations when you're talking about a fraction says do the top part completely, do the bottom part completely, then handle the fraction. There's nothing left to do on top except for I do have a negative exponent, so I'll move it down below. And the y to the negative 5 I'll move up on top. Again, when you move anything opposite where it's at in a fraction, the sign of the exponent changes. The y to the negative 5 becomes y to the positive 5. Y to the third. And the x to negative 2 becomes x to the positive 2. And x to the 7th. Now here we have y to a power times y to a power, so we're going to add our exponents. So that gives us y to the 8th. And here we have x to 2 to the x to the 7th, which gives us x to the 9th. And that would be our answer. Now there's nothing to handle with the fraction after we do that. Now there's one more type I want to talk about before we leave exponents, or this type of exponents I should say. If you have a problem, looks like this. X to the third y over z squared, and I'm raising it to the 5th power. This should be called the distributive property of exponents. It should be called the distributive property of exponents. And it says if everything inside the parentheses is either multiplication or division, and you're raising the parentheses to a power, then take everything inside that power. It's not called a distributive property of exponents, but it figures in the same way. Now notice in this problem, everything inside my parentheses is either multiplication or division. X to the third times y divided by z squared. And we're raising the parentheses to a power. So in this case, we'll take everything inside to the 5th power. So that's going to give us x to the third to the 5th power. That's going to give us y to the 5th power. And z squared to the 5th power. Now remember, when you raise one exponent to another exponent, you multiply them together. 3 times 5 is 15. So we got x to the 15th, y to the 5th. And down here, 2 times 5 is 10, so we've got z to the 10th. And that's our answer. Let me clean that, or clear that off. That's really all of those. Scientific notation I won't cover here. You can watch a video, read the notes on that. Well, let's come down to section R.4. Rational exponents and radicals. We already did a little bit with radicals, but let's talk about the nth roots. I'll show a couple examples to demonstrate it. Let's say 96. We want to find the 4th root. Nth root. Well, my index, the number in the slot, is a 4. So if I put 4 in for the n, I'm going to have the 4th root. So that's what it's referring to when it says the nth root. Well, 96, if I do my prime factorization, and if you're not very good at prime factorization, you can do your tree breakdown. Remembering your primes are 2, 3, 5, 7, 11, sometimes 13. There's actually an infinite number of primes, but you'll find that probably 95% of the problems in algebra revolve around these first 6 primes. So I start my first prime, the 2, and ask myself if this is divisible by 2. It is. 2 times 48. 2's prime, so I circle it. Now I'm still on my first prime, 2, and I ask myself if this is divisible by 2. It is. 2 times 24. 2's prime, so I circle it. 24 is 2 times 12. 2's prime, so I circle it. 12 is 2 times 6. 2's prime, so I circle it. And 6 is 2 times 3. And both those are primes, so I circle them. So we got 3, 4, 5 2's. 1, 2, 3, 4, 5, and 1, 3. Now in this problem our index is 4, which means looking for a set of 4 of something. Well, here's 4 2's. So those 4 2's are going to come out front as a single 2. And we're left inside with a 2 times 3, which is 6. So our answer would be 2 times the 4th root of 6. Okay, let me clean that off. That's evaluating nth roots. Now, simplifying expressions of the form, let's see what in the world that's referring to. That'd be like if you had 16 to the 1/2 power. This is called fractional power form, also known as rational exponents. Rational means single fraction. Now, we can rewrite this back into radical form. And how it works is, using this example, whatever number is in your denominator here, that's your index. That number goes right there. Whatever number's up on top is what goes right in there. But we know if you have a 2, that's just the same as the square root, and first power doesn't add anything, so I can drop that. Now 16 is 4 times 4, and we're looking for a pair of somethings. So here's a pair of 4's. They're going to come out front as a single 4. And that'll be our answer. Now if I had 8 to the 1/3 power. Now again, we put it back in the radical form. So this would be the cube root of 8 to the 1st. Whatever number's in your bottom here, that's your index, goes right there. Whatever number's on top is your power, which goes right there. Now the cube root of 8. 8, if I were to do the prime factorization, is 2 times 2 times 2. Now our index is 3, which means we're looking for a set of 3 of something. Here's 3 2's, so those 3 2's are going to come out in front as a single 2. And that would be our answer. Now let's say I had 8 to the 2/3 power. This is simplifying a number to a fractional power where the numerator is greater than 1. Step 1, put the numerator on the outside of a set of parentheses. Step 2, rewrite what is inside the parentheses in radical form. Step 3, simplify the radical. Step 4, simplify what is left. Okay. Step 1. Put the numerator on the outside of a set of parentheses. So this is going to be equal to 8 to the 1/3 raised to the second power. So we put the numerator, the 2, on the outside of a set of parentheses. Now since there's nothing left up on top, we never leave blank on top or bottom. You always put a placeholder of 1 there. Step 2. Rewrite what is inside of parentheses in radical form. Well, this gets rewritten as the cube root of 8 to the 1st. Again, whatever number's on the bottom here, that's your index. Whatever number's up on top, that's going to be whatever powers goes right here. Step 3, simplify the radical. Well, we got the cube root of 8, and 8 we can rewrite as 2 times 2 times 2. Now we're looking for, our index is 3, so we're looking for a set of 3 of something. Here's 3 2's, so 3 2's is going to come out in front as a single 2. So we got 2 squared. And then step 4, simplify what's left. 2 squared gives us 4. And that would be our answer. Now that was simplifying, it's kind of poorly written here, but a to the m n power and a to the 1 over n power. Now simplifying expressions with rational exponents. Occasionally, you may have problems that use the same idea as our earlier. Remember our different properties for exponents? But these use the same idea as those ones we looked at earlier. We just have fractions. Here we have 5 to the power of 5 to the power. Well, if these are exactly the same, then you subtract smaller exponent from larger one. So we got 3 halves minus 1 half gives us 2 halves, or 1. Which means we're going to have 5 to the first power where our larger exponent was, which is on top. And I'll put a placeholder of 1 here. And 5 to the first is 5, and 5 divided by 1 is 5. And let me go ahead and erase that. We talked about simplifying radicals, so I won't cover that. Polynomials. Key elements of a polynomial, and we'll add and subtract. We looked at adding and subtracting already. Now remember earlier we talked about what a term is. Well, we have something called a monomial, which is one term. We have a binomial, which is 2 terms. We have a trinomial, which is 3 terms. We have a polynomial, which is 1 or more terms. Now standard form is when your terms in a polynomial are arranged from largest power down to the smallest power. Though interestingly enough, you could go from smallest power to largest power. But typically this is what you see the most often, largest to smallest. We've talked about our degree. Degree is your largest power of x. Okay, now we looked at subtracting polynomial earlier, and adding is pretty much the same way. You just combine like terms. So let's take a look at multiplying polynomials. First off, if we have like a 5 and then a x minus 2. This is going to be the distributive property. So we'll take this 5, since it's a single term out in front here. This applies whenever you have a single term here. And we're going to multiply it times each term inside. Terms are separated by pluses and minuses. So we're going to take 5 times x, and we'll take 5 times negative 2. 5 times x is 5x, 5 times negative 2 is negative 10, and that would be our answer. Now in this case we have 2 terms times 2 terms, binomial times binomial. Well, what I'm going to do is take my first term here, the x, and I'll multiply it times each term over here. And I'll take my second term, the negative 7, and multiply it times each term over here. So we're going to have x times x. I'm just following the lines. We're going to have x times 2. Now I'm going to follow blue lines. So I got negative 7 times x and negative 7 times 2. Well, x times x gives us x squared. X times 2 is 2x. Negative 7 times x is negative 7x. And negative 7 times 2 is negative 14. 2x minus 7x is negative 5x minus 14. Always, no matter where you are in algebra, if you can combine like terms, you should go ahead and combine them together. Like terms, same variable, the same power. That's why we combined the 2x and negative 7x. And if they're like terms, you add or subtract the numbers in front of them. 2 minus 7 is negative 5. Then we'll put the x on. Now, special case, identify and simplify special case products. So let's talk about those. If you have 3x minus 1 squared, for example. Now earlier, I said that if everything inside the parentheses is either multiplication or division, and you're raising the parentheses to a power, you can take everything inside of that power. Well, this minus here is what messes it up. That's why we can't square the 3x and square the negative 1. Instead, we have to rewrite 3x minus 1 squared as 3x minus 1 times 3x minus 1. And then I'm going to draw a line, see what to multiply together. I'm taking my 3x here times the 3x over there and times the negative 1. And I'll take the negative 1 times 3x and times negative 1. So 3x times 3x. This is FOIL if you learned that method. First terms multiplied together. Now take 3x times negative 1. That's the outer terms multiplied together. Negative 1 times 3x. That's the inner terms. And negative 1 times negative 1. That's our last terms. 3x times 3x gives us 9x squared. 3x times negative 1 is negative 3x. Negative 1 times 3x is negative 3x. Negative 1 times negative 1 is a positive 1. Which gives us 9x squared minus 6x plus 1. Let me grab another drink here. Okay. Let's take a look at 3x minus 2 times 3x plus 2. Now these are called conjugates. The reason why they're conjugates is the first is the same, 3x and 3x. The last is the same, 2 and 2. But the sign in the middle is different. Here we got a minus and here we got a plus. Now, when you got conjugates, all you have to do is multiply your first parts together, so 3x times 3x, and multiply your last parts together, so negative 2 times 2. 3x times 3x gives us 9x squared minus 2 times 2 is 4. And that would be our answer. Now we're going to see this, there's a couple other places in mathematics where you see this. I was very vague on my defining what I've meant here. I said first is the same. I didn't say first terms. Doesn't have to be terms. If I had, for example, square root of x minus 1 times square root of x plus 1. Notice the first parts are the same. Square root of x, square root of x. The last parts are the same, 1 and 1, but the sign in the middle is different. This is a minus, this is a plus. Well, these are conjugates. So I can multiply the first parts together, square root of x times square root of x, and negative 1 times 1. Well, square root of x times square root of x gives us x, minus 1 times 1 is 1. It does not matter where you are in mathematics. If they're conjugates, it always follows that same principle. You see the same thing when you're talking about imaginary numbers. You got 3 plus I times 3 minus I. Notice how the first part's the same, last part's the same, but sign in the middle is different. Same idea. If you are going on trig, and you had sine x plus 1 and sine x minus 1. Well, same thing here. The first part's the same, last part's the same. So they don't have to be terms. Don't get thinking that that's true. It's true in this section, but not always. Now we referred to multiplying a radical expression together, but let's explore that a little bit more. Let me clear this off. If we are multiplying square root of 2 times square root of 2. When you're multiplying radicals together, what you do is you multiply what's underneath them and put them underneath a single radical. So square root of 2 times square root of 2 becomes square root of 2 times 2. And then you can simplify these. This is our square root. We're looking for a pair of somethings. So here's a pair of 2's. They're going to come out in front as a single 2. And that'll be your answer. If, on the other hand, you had square root of 3 times square root of 6, here we'd have square root, and you multiply what's underneath, 3 times 6. Now, you don't want to actually multiply those together. You want to see what can simplify. Now, 3 is prime, so it's broke down as much as it can be, but 6 is 3 times 2. Well, remember, we're looking for a pair of something, so here's a pair of 2's. They're going to come out in front as a single. The pair of 3's comes out as a single 3. So our answer is 3 square root of 2. Now, this same principle holds true when you got different indexes. If I had the cube root of x times the cube root of x squared, assuming all my variables are positive, then we'd have the cube root of x times x squared. Now our index is 3, and I need to rewrite the x squared as x times x so I can see what I have. Now once I do that, my index is 3, so I'm looking for a set of 3 of something. Here I got 3 x's. Those 3 x's are going to come out in front as a single x. And that would be our answer. Let me erase that. And let's take a look at factoring. For our factoring, our first technique is GCF. And that stands for greatest common factor. Our second method is grouping. And this is when you have 4 or more terms. Our third method is dots, which stands for difference of 2 squares. And this is when you got 2 terms with a minus between them. And then we got PSD, which is of the form x squared plus bx plus c. And we got key number, which is of the form ax squared plus bx plus c. We got difference of 2 cubes, which is 2 terms with a minus between them. And we got sum of 2 cubes, which is two terms with a plus between them. Okay, so let's take a look at some examples. Let's say I have 15 x to the fourth minus 25 x squared. Now, GCF is what we're going to look at here first. And number-wise, you look for the largest number divides into both of them. So 15 and 25, largest number divides in both those is 5. Now here we have x to the fourth and here we have x squared. You want to factor out the most x's you can, but you can't bring out 4 x's if you only have 2 x's. So it's always one of the smallest exponent. So I'll bring out an x squared. Now factor means to divide out. So 15 divided by 5 is 3. I always tell people when they're learning factoring for the first time, you visualize it. I have 4 x's sitting on my table. Somebody comes and takes 2 of my x's. How many x's do I have left? Well, I have 2 left. You subtract the exponents basically. Minus 25 divided by 5 is 5. I have 2 x's. I take 2 of them away, so there's no x's left. So this would be our answer. Now this one, there's a note that goes along with it for GCF. And note says, for GCF, if your first term is negative, always factor out a negative. Okay, so on this problem, I see my first term is negative, so I know a negative's coming out. Now 3 and 9, the largest number divides into all those is 3. Well, negative 3 divided by negative 3 is 1 with an x. 9 divided by negative 3 is negative 3. So we're going to have negative 3 times x minus 3. And that's our answer. Let's say I had a problem, ax minus ay plus bx minus by. Now I start going through my list. GCF, well, they don't have anything common. Some have A's, some have B's, some have X's, some have Y's. But if I look at all 4 terms, they have nothing in common. So next method says when you have 4 or more terms, you try grouping. Well, we have 4 or more terms here. And when I say grouping, you group first 2 terms together, and group the last 2 terms together. Now the first group has an A in common, so I factor that out. And that gives me x minus y. My second group has a b in common. I factor that out, and that gives me x minus y. Now your goal with grouping is to get this parentheses same as this parentheses. They are. So I'll factor out an x minus y out in front. And to see what goes in your second set of parentheses, you go up to the previous step, cross out what you factored out, and what isn't crossed out is what goes right here, which would be a plus b. And that would be our answer. Let's see, x is 20x plus 4. Let's say we got x squared minus 16x minus 80. And we want to factor this. Well, GCF, we don't have anything in common. Grouping is 4 more terms. No. Difference 2 squares. Nope. PSD. X squared. The form we're looking for here is x squared x, no number in front of our x squared. Well, x squared x, no number in front of our x squared. So this is PSD. Now with PSD, you take the number at the end, this constant term, and you ignore signs. So if it's a negative, you look at positive 80. If it's positive 80, you still look at positive 80. Then we're going to come up with 3 columns. Our P column, the P stands for products. So we're going to write down all the products to give us 80. We got 1 times 80, 2 times 40, 4 times 20, 5 times 16, 7 no, 8 times 10. Then the S column. The S stands for sum. We're going to add these together. 1 plus 80 is 81. 2 plus 40 is 42. 4 plus 20 is 24. 5 plus 16 is 21. 8 plus 10 is 18. Now the difference column. We're going to subtract smaller from larger. 80 minus 1 is 79. 40 minus 2 is 38. 20 minus 4 is 16. 16 minus 5 is 11. 10 minus 8 is 2. Now a number we're looking for is a number in our middle term, which is 16, which is right here. So we're going to use 4 and 20. Now last thing we need to do is determine what our sign is going to be. We got a note to help us with that. And this applies not only to PSD but key number. It says the larger number from the P column that we are using is always the same sign as the middle term. Then we also have something that helps us. If it's in the S column, it's S for same signs, both positive or both negative. If it's in the D column, D for different signs. Means one will be positive and one will be negative. Okay, larger number from the P column that we're using is always same sign as middle term. We're using 4 and 20, so larger of those is the 20. It will always be same sign as middle term. Our middle term is negative, so the 20 will be negative. Now the number I circled is in the D column, so D for different signs. One will be positive, one will be negative. So if this one's negative, that means this one has to be positive. And that would be our answer. Let's look at one more of those. So we got x squared minus 25x plus 100, and want to factor it. Well, if I come up here, there is no GCF. Grouping is 4 or more terms. We only have 3 terms. Dots we haven't talked about, but that's 2 terms of minusing it. But key number, or PSD, this is where you have an x squared x, no number in front of x squared. So x squared x, no number in front of x squared. This is PSD again. Now PSD would take the number at the end, ignoring signs. And we're going to come up with our 3 columns. Remember the P is product. All products give us 100. So we got 1 times 100, 2 times 50, 3 no, 4 times 25. If you're not very good at coming up with these, just plug them in your calculator. Do 100 divided by 2 should give you 50. 100 divided by 3 gives you decimals. If it gives you decimals, it doesn't go evenly. 5 times 20. 6 no, 7 no, 8 no, 9. I think 10's the next one. 10 times 10. Now the S column. We want to add these numbers together. 1 plus 100 is 101. 2 plus 50 is 52. 4 plus 25 is 29. 5 plus 20 is 25. 10 plus 10 is 20. Difference column. Subtract smaller from larger. 100 minus 1 is 99. 50 minus 2 is 48. 25 minus 4 is 21. 20 minus 5 is 15. 10 minus 10 is 0. Now remember, the number we're looking for is a number in a middle term, which is 25, which is right here, which means we use 5 and 20. Now our note says the larger number in a P column we're using 5 and 20, so 20 is the largest one, will always be the same sign as the middle term. Middle term is negative, so that'll be a negative. Now the number I circled is in the S column. S for same signs, both positive, both negative. So if this one's negative, this one has to be negative. And that'll be your answer. Let me clear those off. Grab a drink. Okay, let's take a look at let's see, 2x squared plus 9x minus 5, and want to factor this. GCF, there's nothing here. Grouping is 4 more terms. This is 3 terms. Dots is 2 terms with minus string it. Well, this is still 3 terms. PSD is close, but there's a number in front of the x squared. Now the key number is when we have an x squared, x, no x, and there's a number in front of our x squared. X squared, x, no x, number in front of our x squared. So this is key number. Now with key number, we're going to take our number at the beginning times our number at the end, ignoring signs. When I say the number at the beginning, I'm talking about the number that's before x squared, the coefficient. When I say the number at the end, I'm talking about the constant term. And again, we ignore the signs, so we don't worry about that negative. We handle signs later on. 2 times 5 is 10. Now we're still going to use a PSD table, we're just going to use it differently. Now 10 is 1 times 10 for products, and 2 times 5. The sum column, 1 plus 10 is 11. 2 plus 5 is 7. The difference column, subtract smaller from larger. 10 minus 1 is 9. 5 minus 2 is 3. Now we're still looking for the number in our middle term, which is 9, which is right here, which means we're going to use 1 and 10. We're just going to use them slightly different than the previous method. Now the first term remains as is, the last term remains as is. We're going to use these two numbers to rewrite our middle term. Now all of our notes on our sign still holds true. The larger number, we're using 1 and 10, so a larger one is a 10, will always be the same sign as the middle term, which is positive. Now the number I circled in the difference column mean different signs. So if the 10 is positive, the 1 has to be negative. And you can see we're just going backwards, combining like terms. 10x minus 1x would give us our 9x. What's the benefit of doing this? Well, then we can use factoring by grouping. The first group has a 2x in common, and that gives us x plus 5. The last group, the first term is negative, so I factor out a negative 1. And that gives us x plus 5. Now our goal was to get these parentheses the same, which they are. So I'll factor out an x plus 5. And remember, to see what goes in your second set of parentheses, you can go up the previous step and cross out what they have in common, what we factored out, and what's not crossed out is what goes right here, which would be 2x minus 1. And that's our answer. Let me clear that off. And let's take a look at 16x squared minus 9. Okay, GCF, don't have any. Groupings, 4 more terms, no. Dots, 2 terms with minus string it. 2 terms with minus string it, that fits. So we're going to try the difference to 2 squares. Doesn't mean it'll work, but we try it. With the difference to 2 squares, you try to rewrite it as something squared minus something else squared. You take a look at each individual piece and you ask yourself what times itself gives you that. For example, 16, 4 times 4. For the x squared, that's x times x. And for the 9, that's 3 times 3. Now I'm going to label what's inside these parentheses. I'll label this as F for what's in my first set of parentheses, and I'll label this as L for what's in my last set of parentheses. Now the difference to 2 squares is just a formula. F plus L times F minus L. Now everywhere there's an F, we're going to plug in 4x, and everywhere there's an L, we'll plug in 3. So we got 4x plus 3 times 4x minus 3. And that would be our answer. Now let's say we had an x to the third minus 8. I'm going to try difference 2 squares again. I try to write this as something squared minus something else squared. But then I realize that there's nothing times self will give you 8. Nothing times self gives you x to the third. So it fails. Well, x to the third minus 8. As we go down through our list, you'll notice that this says 2 terms with a minus between them. But this one down here also says 2 terms with a minus between them. So this is going to be difference of 2 cubes. And we try to write this as something to the third power minus something else to the third power. Now, instead of asking yourself what times itself gives each individual piece, you ask yourself what times itself 3 times gives each individual piece. For example, the x to the third, that's x times x times x. For the 8, that would be 2 times 2 times 2. Now I'm going to label what's in the first set of parentheses as F for first, and I'll label what's in the last set of parentheses as L for last. And our formula for the difference of 2 cubes says F minus L times F squared plus FL plus L squared. Now everywhere there's an F, I'm going to plug in x, and everywhere there's an L, I'll plug in 2. So we're going to have x minus 2 times x squared plus x times 2 plus 2 squared, which gives us x minus 2 times x squared plus 2x plus 4. And that would be our answer. And one last one. Let's say we got x to the third plus 27. GCF? No. Grouping is 4 more terms? No. This is 2 terms with a plus between it. Dots? 2 terms with a minus between it? No. This is a plus between it. PSD and key number both 3 terms. That doesn't fit. Difference 2 cubes. 2 terms with a minus between it. Again, that doesn't fit. But sum of 2 cubes. 2 terms with a plus between them. 2 terms with a plus between them. That would work. Or it's something we could try. It doesn't mean it'll work. It'll work if you can rewrite it using this form right here. We take a look at each individual piece, and you ask yourself what times itself 3 times gives you that. X to the third, well, that's x times x times x. And 27 is 3 times 3 times 3. So we were able to rewrite it in this form. So I'm going to label what's in my first set of parentheses as F for first, and I'll label what's in my last set of parentheses as L for last. This is a sum of 2 cubes, which formula-wise is F plus L times F squared minus FL plus L squared. Now everywhere there's an F, I'm going to plug in x, and everywhere there's an L, I'll plug in 3. So we got x plus 3 times x squared minus x times 3 plus 3 squared, which gives us x plus 3 times x squared minus 3x plus 3 squared, which is 9. And that would be our answer. Now, I didn't get to R.7, but I put YouTube videos out there, so you can go watch those. I definitely recommend that. The YouTube videos you'll find under each unit. Here's Instructor YouTube Supplemental videos. Now these aren't shortened lecture videos like you're getting right now, but these are full lectures, so they may take a little while to go through. I'm not sure if you want to actually read or watch each one of those, but if there's a particular area where you're struggling, then go out there and watch that. And I think it'll help you in terms of understanding the material. A little bit of time put up front on these videos will give you that foundation that'll help save you time in later units. I'm going to go ahead and stop the recording here, and then I'll answer any questions you have.